All right, guys, so I want to take some time to go over the conceptual analysis of series and parallel circuits. So these are the multiple choice questions. All right, so remember for a series circuit, the voltages add up, and for a parallel circuit, the voltage is the same. So applying that concept, number one says, consider the power delivered to each of the resistors shown in the circuit below. Which circuit or circuits have the least power delivered to it? All right, so let's say this battery right here is 10 volts. If this is 10 volts and the voltages add up for a series circuit, this has to be 10 volts as well, because where else is the voltage going to go? Now for circuit 2, if this battery is 10 volts, then since they're all parallel, this one's going to be 10 volts, and this one is also 10 volts right here for this resistor. Now right here, if this is a 10 volt battery and this is a 10 volt battery, since this one is in series, those voltages would add up for the resistor. So this resistor would have 20 volts. So this resistor gets all 10. This resistor gets 10 volts because it's in parallel. This one gets 20 volts because the voltages add up since it's a series circuit. So the question asks which one gets the least power delivered to it. So power is equal to IV. Since these resistors have the smaller V, it's going to be circuit 1 and circuit 2, which would be option D. All right. Number 2, compare the brightness of bulb A in circuit 1 with bulb A in circuit 2. Which bulb is dimmer? Now, again, let's say this is 10 volts. Bulb A in circuit 1 will be getting all of that 10 volts. And then for circuit 2, if this battery is 10 volts, then everything in parallel is going to be 10 volts. So the voltage of A in circuit 1 is 10 volts, and the voltage of light bulb A in circuit 2 is 10 volts. So the correct answer is C. They're going to have the same voltage, the same power, the same brightness. Now for number 3, compare the energy delivered per second to the light bulb in circuit 1 with the energy delivered per second to the light bulb in circuit 2. Which bulb or bulbs have the least energy delivered to it per second? All right. Which one has the least energy delivered? First, energy is equal to the power times time. So whichever bulb has the lowest power will be the bulb that has the less energy. All right. So again, circuit 1, if this is 10 volts, light bulb A is going to get all 10 volts. Then for circuit 2, if circuit 2 is the battery is 10 volts, since this is a series circuit, they have to both add up to give you 10 volts. So it's going to be 5 volts here and 5 volts here, which is going to give you that the light bulbs with the lowest energy is going to be light bulb B and C since the voltage is lower. So the correct answer for number 3 is D. All right, number 4. What happens to the potential difference between points 1 and 2 if bulb A is removed? So if this is 10 volts, this resistor is 10 volts, and this one's 10 volts. Now, if I take away A, what happens to the voltage of B? It will get all 10 volts, which is the same as what it got before. So all of them are getting 10 volts now, but even if I take away A, that whole 10 volts is just going to be going to resistor or light bulb B. So it's going to stay the same. So the correct answer for number 4 is stay the same. And then flipping over to the back, number 5, what happens to the brightness of bulb A and B when the wire is connected between points 1 and 2? So right here I have a parallel circuit. If I connect a wire between 1 and 2 without any resistor on that wire, current's going to flow. Some of it's going to go this way. It can go that way or go straight. Some of the current's going to flow. It can go straight or go that way. But ultimately, this is still a parallel circuit. And it's the same parallel circuit because I didn't add a resistor. All I did was add a wire. So the question was, what's going to happen to the brightness? The brightness is going to stay the same because all I did was add a wire and it stayed a parallel circuit. All right, number 6. Compare the brightness of bulb A in circuit 1 with bulb A in circuit 2. Which bulb is brighter? So if this is 10 volts, this bulb gets all 10 volts. And then for circuit 2, if this is 10 volts, since the series circuit, it has to break down 5 volts and 5 volts. So which one is going to be brighter? The one with the most voltage, which is the 10 volt light bulb in circuit 1. So bulb A in circuit 1. All right, now number 7 is a little bit interesting. This is probably a more difficult question. On here, it says, if you increase the resistance of C, what happens to the brightness of bulbs A and B? So if this R gets bigger, if V is equal to IR, if this R gets bigger, this V gets bigger. So it's going to take away some of the voltage of A and some of the voltage of B. So that means if we increase R for C, the voltage for A and B gets lower, so those are going to get a little bit less bright. So it's going to be A and B, the brightness both decrease for them. You can also look at this mathematically. Let's say this is a 10 volt battery. Actually, let's say it's a 12 volt battery. So this is going to be 4 volts. This can be 4 volts. This could be 4 volts. So if I calculate the equivalent resistance, it's going to be a certain number, which I don't know. Oh, sorry. Sorry, I thought about this wrong. So let's say each one is 4 ohms. That's what I meant to say. The equivalent resistance is going to be 12 ohms, and the total voltage is 12 volts. And that means the current is going to be 1 amp, the total current. So this gets 1 amp, this gets 1 amp, this gets 1 amp. Now if I calculate the voltage for bulb A, it would be IR, which would be 1 times 4, which is 4 volts. VB is 4 volts. VC would also be 4 volts because 4 times 1, 4 times 1, 4 times 1. All right, now it said what happens to the brightness when I increase the resistance of C. So now let's say this is 4. Well, let's say this is 8 volts. 8 ohms. This is 2 ohms. And this is 2 ohms. So, if this is 2 ohms, 8 ohms, and 2 ohms, then what's going to happen is my equivalent resistance will still be 12. My total current would be 1 amp. But since I increase C, C is higher than A and B, when I do V is equal to IR, I'm going to do 1 times 2. So this would just be 2 volts. I'm going to do 1 times 2. This would just be 2 volts. And then I'm going to do 1 times 8, which is 8 volts. So C would get brighter and A and B would get dimmer since those would only be 2 volts and this is 8 volts. So that's a mathematical way we can look to see why A and B decrease. And then number 8 says, what is the potential difference between point A and point B? So if I were to take a voltmeter and connect it to point A and point B, this is my voltmeter, I would get this measurement of 12 volts since that's in between point A and point B. So it will be 12 volts. Now, if B was right here and I tried to measure it, it would be 0 because there's no voltage in between. So in that case, it will be 0. But the reason the switch is open is just so you can know that you have to measure the voltage this way. You can't measure it that way because it's going to be 0 because it's open. So you can't measure it that way. So you have to measure it this way. All right. So I hope this video helped you guys a little bit understand it. Circuits conceptually with voltage and power and brightness. So let me know if you have any questions.